Today we are going to discuss about removal of hardness. So we are using water for different purposes. You know why we concern about hard water? Because now we are using water for many purposes like agriculture, domestic and industrial purpose. But due to poor rainfall and the lacking in the storage of water resources, now we are depends on the underground water. The underground water is a little bit saline compared to the fresh water. Say for example, river. When we can go to that sea water, it is more saline compared to this underground water. Though it is being stored on the surface, it is more salty. So that's the reason that we know already. So we have to use the water in the underground resources. It is rich with salt. Okay. How this water is rich with water? When the water falls over the surface, it will dissolve the minerals present in the soil and the dissolved salt get enter into the water. So the water become more saline. Okay. So what happens if you are using that salty water for regular uses, even in the domestic side, you can able to notice that there is a white deposit over the container, kitchen vase, as well as on the kitchen table, in bathroom and toilets. You can note that there is some white deposit over the surface. Sometimes at the beginning we can able to remove it easier, but later stage it is very difficult to clean it. Okay, it is over the surface. This issue means when you can come to the pipelines and all that, it will be more deposit and it does not allow the flow of the water. So this is because of the deposition of that salt as a strong adherent material which is called as the scales. So in order to avoid the scales which is deposit over the pipelines and other flow areas, as well as it will affect the quality of our materials. Suppose if you are going for the pharmaceutical industries or food and beverages, it will affect the process as well as the quality of the product. So it is important to go for the purification of water. There are so many methods which is available, but for industrial purpose we need a large amount of water. So we can go with some technical aspects which is pertaining to the ion exchange process. So first we have to see that zeolite method, which is what is this zeolite? Zeolite is nothing but sodium aluminum silicate. It is naturally available, but it is non-porous in nature. When we have synthesized the same zeolite in our laboratories, it will be porous in structure. Can you able to see that porous nature in the membrane? So this cross-linked network which contains the pores, that is micropores of the zeolite, which is very useful for the removal of the hardness producing substance. So the calcium and magnesium ion, which is mainly responsible for the hardness of water, and this is import other problems like corrosion, caustic embrittlement, etc. So we have to remove the calcium and magnesium. This is our primary. You can see the outline of this zeolite softener. So there is a column which is filled with the zeolite. So zeolite we have to make into powder and we have to tighten the column with a hard tight. Okay, these are, and then we are allowing the hard water from the top of the zeolite softener in the spray method. Okay, so what happens when the hot water is allowed to fall on the surface of the zeolite bed? The hot water start penetrating through the pores in the zeolite bed. What happens there? The sodium present in the sodium zeolite has been replaced with the hardness producing substance, that is the calcium and the magnesium. So once the water coming out in the outlet which contains only the sodium salt. The other, not only the calcium and magnesium, other ions has also been replaced with the sodium. So the water which comes out, which contains only the sodium salt of the water. So with the sodium salt is not a hardness producing substance, so we can use that water for the other purpose, but depends upon the utility. That is where we are going to use. That limits the this method, because it is rich with the sodium salt, so we have to move with another method. That is another method, that is a demineralization method. Okay, before we are going to see that, we have to take into consideration at how long this bed will work. Okay, so it will be converted the hot water into soft water as long as the sodium ion is available in the zeolite bed. Once all the sodium ion in the zeolite bed has been removed, the bed is said to be exhausted. Okay, so what we are going to do with that? We have to recharge. So how to recharge? We have to allow 10% sodium chloride solution over the zeolite bed. It will remove the other ions, and now once again the sodium is retained into the zeolite bed. So once again we have to allow the hard water to pass through that, and we have to collect the soft water. Another method which is superior over the zeolite method is called the ion exchange method. So what is happening here? Here the ion exchange is nothing but a polymer resin which contains polar groups which consists with a H plus, either H plus directly or COOH or SO3H. This kind of a resin is used as a cation exchange resin. So another resin, we are using another resin which is called ion exchange resin, which contains the polar group OH, NH2 like that. So we have two columns. We have to take two columns. The one column is filled with cation exchange resin, and another column filled with anion exchange resin. You see that this is the cross-linked network of the polymer resin which contains the active group. So that H and OH has been replaced with our ions dissolved in the water. So the cation exchange resin. So this is a second one is the anion exchange resin. So the hot water is allowed to first pass through the cation exchange resin. Here what will happen? Whatever the positive ion present in the water is being replaced with the H plus ion of the resin. Okay, so the water which comes out from that cation exchanger will contain only the H plus ion as the positive ion, and the rest of the negative ion is there. So now the water is allowed to pass through the second column which is filled with anion exchange resin. Here the OH of the resin is replaced with the negative ions like chloride, sulfate, phosphate and other ion dissolved in the water. And now you can see that the water which comes out from the second exchanger will contains only H plus and OH minus. So that is nothing but pure water. Okay. So in this method we are getting the pure water, but it is not suitable for drinking purpose because it just removes only the ions present in the water and not the microorganisms. So it can be used for industrial purpose and not for the domestic, that is particularly for the drinking purpose. Okay. So here also the exchange resin will work to certain extent. Okay. After that the resin will be said to be exhausted. Once it is being exhausted, you can stop the passage of hard water. And now the cation exchanger is washed with dilute hydrochloric acid. And then the anion exchanger resin is washed with dilute sodium hydroxide. So once it is being washed thoroughly and it will be discarded, and now the resin is getting refreshed, that is, it is ready for the next removal of the ions which is present in the water. Thank you.